One that we didn't get a chance to talk, right? There's a big piece of that was part of that mission. And
No, I don't need to be on stand. I just need to go to the
It looks like a launch. Yeah, it looks like a.
You guys are aware of Spacecraft 3. We've brought it back successfully. You can see on this side, this is our what we call the leading edge as we come through re-entry. And so this is where we'll pick up the most heat as the vehicle goes through the atmosphere. You can kind of see the front side where the tiles are. That's designed to take that heat. And then the heat shield and its ablative characteristics as it comes off, it'll tend to come up and over the vehicle, whatever. And so you can see a little bit of that residue on the front, as well as the darker stripe. There's one on this side and one on the other side. So that's kind of the science behind bringing a vehicle back and dissipating all that energy that you've got from being on orbit.
How'd she perform?
The vehicle performed really well from both just the whole mission. Beyond our software anomaly that we had, the vehicle did everything we asked it to do. The propulsion system worked really well. The life support system. We had a really good, tight vehicle. We were able to control the temperatures that we needed to do. And so we're real happy with the performance of the vehicle.
Is the charring about what you expected?
From our, we got a lot of data that we're going through right now. And so from a ablative standpoint on the base heat shield, it was what we expected. The actual effects that you get on the vehicle, those are going to be a little bit new, and we'll learn as that goes through or whatever. But we're not seeing anything on the vehicle that's causing us any concern or alarm.
What's going to need to be done to the tiles before it would fly again?
So we basically, from a tile standpoint, we'll just clean it up. And we'll go through and we'll just kind of take off some of that surface deposits that are on there. For the blankets that go up the side, same thing. We'll go in and we'll just kind of clean it up. Most of it is aesthetics, just the look of the vehicle. But from a standpoint of reusability, this is designed for 10 missions, and so we're happy with the performance.
Are the scorch marks cosmetic, or are they actually?
They're cosmetic, right? So it's
clean that off?
most of that should clean off. Now it might be a little discolored.
You should sell that on.
Oh, yeah. So we'll get in there and we'll have some a little bit of abrasion compounds and whatnot. We'll take most of that off.
So you said just cleaning up the tiles was just cosmetic. If it's just cosmetic, why do it?
You want to make sure that you don't have buildup. If you build up layers, now you start affecting the aerodynamics of the vehicle, and so you don't want to continue to do that. So a little pride in our work too, right? We want to make sure that vehicle is clean and is as factory fresh as we can make it for the next mission.
Speaking of pride, just how proud are you and the team right now to see this thing back here and ready for another flight?
The team's really excited, and of course you can see around the factory we've got a couple vehicles in flow right now. So we're doing a lot of our external inspections now. We'll get the back shells off, and the team's just dying to get inside and see how the internal parts of the systems worked. We're going through a lot of data now, and so we're learning tons, right? This is really a good learning opportunity for us, and the team's really excited about going and doing it again.
Are the astronauts coming out and taking a look at it?
We've had the astronauts here a couple times, and they're part of our data reviews also, which is really engaging, right? They ask really good questions, and we want to make sure that they understand what this vehicle is about, and so they've been very, very involved in what we're doing.
Do you have any data from Rosie yet? From the
data is off. It's part of what's being analyzed. Some of the just at the lower level, and got video also of watching that landing. Very soft landing, right? Very, very benign landing compared to what we've designed for, right?
Both video on the inside of the capsule?
Video on the inside too, right? So
we just posted like a 3-minute video on YouTube.
You did of that?
It's available for download on our Dropbox.
And is it on Rosie?
Right. So you'll see just a nice flat landing or whatever, and so lots of instrumentation, accelerometers, temperature measurements. So that's what the team's going through right now to compare that to our models.
How much you mentioned the stuff that you can only get now that it's back, but how much of that data was downlinked live?
A lot of it was, right? We got a lot of data that came down in real time, and so we've got teams in our engineering support rooms that are monitoring that real time, along with the flight control team in Houston. And then we also record a lot of data on the vehicle. So that data came off once the vehicle landed. It's been distributed to the teams, and now they're doing their analysis.
Is there any part of the inner workings of the capsule that are going to be removed that wouldn't have been if there hadn't been a timer problem?
No, from a vehicle standpoint, the idea is that we'll go in, we'll take the cargo out, Rosie will come out, she only got one ride, right? So we'll refurbish inside and get it ready for its next mission. There'll be different payloads that we'll fly depending on the PCM missions that we're flying. But then everything else on the outside of the vehicle, it's just a refurbishment, right? So it's putting on expended hardware, cleaning up like we talked about, resurfacing the consumables, recharging batteries, those sorts of things.
What I meant specifically is like any of the flight computers, anything that's going to have to get pulled as part of the investigation into the timer anomaly.
Yeah, so we don't have to pull any of the boxes. We're able to download the data straight off of them. So there's, just like you have at your house, right? You just plug into it and we can pull the data off. So.
If NASA doesn't require you to do another OFT, obviously this data is going to be critical in proving that you can do this safely with astronauts. So what are they looking at? Like what data, like how do you use this data to prove that you don't need to do it again?
So, from a reflying OFT or moving straight into CFT, that's a little bit forward work for us here, right? Right now we're trying to see what did we learn from this vehicle independent of, whether we need to do another OFT or not. And so it's all about the performance of the electrical systems, the fluid systems, the thermal systems, given that we spent a couple days on orbit and how that vehicle responded. And what we do is we'll compare that to all the analysis that we've done beforehand, right, to understand if we match up to our models. That'll go a long way towards whether it's another OFT flight or a CFT flight, just us saying, hey, we are confident, we understand this vehicle, we don't need to make any changes, and we're ready to go fly again, whatever that mission is.
So the data that you got back live, specifically for the launch, did it match about what you were expecting in terms of like the vibrations, the G-forces, the crew would experience, things like that?
Yeah, so when you say launch, you mean the ascent part
Yes.
of it? Yeah. So most of that data was recorded. We didn't get a lot of that data until we got it back, right? But we did get some camera views, early on, and got to see kind of some of the active dynamics there or whatever. So, but again, most of that data, it's very high data rate, and so it's not something you can telemeter down. It has to be recorded, and then we got it post-mission.
So do we have a corresponding stripe on the other side also?
There was. If we can kind of walk this way if you want to look, but you'll see a very symmetric stripe, just like this one on the other side.
And where did the heat shield end up?
So the heat shield falls off.
Yes.
You saw that?
Who has it?
We have that. Honestly, I don't think it's made it back here yet. But we'll go through that, and the teams will, they'll do some forensics on that to learn about how much the heat shield ablated.
Sure.
We'll look at it structurally, and we'll use that as. A lot of times, data doesn't come from a piece of ones and zeros, right? It's actually putting your hands on the hardware and doing some forensics on the hardware.
So I don't think I've heard this number specifically, but in percentage-wise, how much of the capsule is reusable for those 10 missions versus the new stuff that you have to swap out every mission?
I don't know if I've got a percentage, because it could be in terms of weight or part counts or whatnot, but
Part counts?
oh my goodness, probably 98% of the part count is reusable, right? So it's the things that you don't see here that we would have to refurbish, right? So the base heat shield's clearly not here. The forward heat shield, the ascent cover, those are lost as part of the jettisons once you come back. But pretty much everything you see here, even the airbags, we'll refurbish those and they'll get reused whether it's not on this mission or another mission. But pretty much everything you see here is reusable.
Just for the tape, will you tell us your name again, please, sir?
My name's Tim Ruff.
And spell your last name.
It's REITH.
And your title.
And I am the spacecraft engineering manager.
Thank you so much.
For this one or for all of them?
For the program. So
Does mission manager work?
is what?
What was your title again?
Spacecraft engineering manager.
Thank you.
How different is the refurbishment and processing for this vehicle as compared to what you've sort of laid out for the operational missions as far as time or scope of work? And I understand this one is maybe a little more extensive time-wise because of the investigation, but in general, what is the turnaround time for this capsule compared to what you're sort of
They're actually not
ballparking for
much
the
different.
rest?
They're actually not much different, right? Like I said, most of the time is generic to any mission, right? Whether it's cleaning it up, redoing the airbags, cargo in and out, resurfacing all the consumables. That's a pretty standard mission that we'll have. And so the investigation will go on, and that will look into the aspects of the software, but it's really unrelated to us refurbishing the vehicle.
So, and what is the turnaround time then?
It's roughly 6 months that we would turn vehicles around.
So let's back up a little bit. The capsule arrived here, and what were your thoughts when you saw it for the first time? You know, it's finally back from space, back from the desert. What did you think when you saw it?
So it's really exciting, right? You see the big truck pull in with the container, and they offload it. And when the lid comes off, everybody's really excited to see it again, right? We saw video of it, in the desert, but to actually get up this close and to be able to see it again, a lot of pride in the team, right? Knowing that this is something that we built, that and it successfully performed the mission that we asked.
You got your baby back.
That's right.
So then, when you looked at it, and you're just kind of checking it out, kicking the tires, what are you thinking about how it looks?
It actually looks better than some people would have thought, right? You just never know, right, when it comes to how it's going to perform during a re-entry. But this vehicle looks very clean. I mean, as you kind of walk around, we're actually on the dirty side, right? If you were to get a look on the other side, it looks like it's brand new. It really is.
So I will say we got super lucky because we position our cameras on landing based on the wind. We're always upwind of the vehicle in case there's a fuel leak, and we just happen to give you guys the look at the pristine side during the show.
I think that got a few of us who were like, wow, that looks clean.
I didn't see this side until it came back.
Right.
Should have known.
So this one will be turned around for the first post-certification,
Correct.
And so this one and the crew test flight will be the one. Is there any plan to fly the pad of work test vehicle?
No plans to refly this one. Of course, it was in a full-up vehicle, right? We didn't have our life support systems and things that we did need for pad of work. So this vehicle, we've got some options to go off and do. There is some hardware on there that's valuable to us, and so we may use it as from spares and standpoint and whatnot. If we do have some sort of anomaly in the future, we could always consider, can we go use that vehicle as a test bed? But yeah, no plans to refly spacecraft 1.
So that's a service module for the crewed flight capsule. So when is that going to be ready to go?
So it is almost ready to go into our processing facility. They're just putting the last of the covers on, and so I would say in the next week or so, we'll go through the pressurization and a lot of the hazardous operations of leak checks that we'll do in the HPA, and then it'll just be ready to be serviced once the crew module.
So a couple weeks, a month?
So it probably takes about a month or so to finish all that testing, and it'll be ready.
And the actual crew test Starliner, it's looking a little naked over there.
Sure.
How many months does it have left before?
So it's got
ready?
Our plan is to get it fully configured, so you'll see the back shells and everything are not on it now. We want to get the back shells on it probably within the next couple weeks, and then that'll finish closing out all the interior, and then we'll start doing some what we call our acceptance testing of that vehicle, right? We'll run through a whole series of tests, making sure all the systems work. That timeline will then match up with the service module, and then when both vehicles are ready, put them together, fuel them up, and we'll be ready to head to the launch pad.
So a couple months?
And it does look naked, but those back shells go on in less than a day. It takes about 6 hours to get them on. So this does make it look pretty, but it's not in depth.
How many back shell panels are there?
Like 4, yeah.
Okay.
4 around, yeah, quadrants.
What was your initial reaction to seeing the spacecraft back?
Sense of pride, a sense of that we committed to safety and quality first and foremost of the vehicle because how pristine it looks as it returned to Earth's atmosphere.
What was the first thing you guys did?
The first thing we did.
Once it was in here?
Once it was in here, we began to assess the vehicle. Believe it or not, the vehicle will talk to you if you look at it visually. It'll tell you how it performed without even pulling data on it. It would tell you how it performed. And this vehicle performed as it was designed to perform. And it's in pristine condition today. We learned that the TPS on the vehicle, the thermal protective system on the vehicle, performed extremely well. It did what it was supposed to do. The entire landing airbag system, the parachute system, everything worked properly. That's what we've learned so far. And that's an attribute to everybody in this building, everybody on the program. Right? They dedicate holidays, weekends, they miss baseball games, softball games, birthday parties, all for one thing, and that's for the mission to get astronauts back to the International Space Station from the U.S. soil.
It's a family affair, right?
It absolutely is. Our employees' families own this success as much as they do. They sacrifice unbelievably to ensure that the U.S. is going to be self-sufficient.
Hey, can you walk them through what's next for this vehicle, what you guys are going to do to get it ready for whatever's next?
Yeah, absolutely. So again, the vehicle performed extremely well, right? And we're very proud of the vehicle. Looking at the vehicle behind me at a very high level, we will focus on repacking parachutes, repacking drogue mortars that you see on the top of the vehicle that are gone and used up. We will also take a look at removing the back shells off of the vehicle, which will look like that once we remove the back shells. And once we're underneath the back shells, we can go and assess everything else that makes this vehicle what it is today. Right? And we'll look through the propulsion systems, the fuel systems, we'll look through the parachute landing bag systems, the LRS system. We'll go through all of that to ensure, again, that the vehicle performed like it should have performed, okay, and we know it did, and that it's going to be ready to turn around quickly. One thing we will not do is we'll never jeopardize safety and or quality for a schedule, and we will never ever fly this vehicle unless it's ready.
It's got to be just that particular craft has got to be special to you and your team.
Absolutely. You know, it's the first of a lot of things for this particular vehicle. First and foremost, it is getting us back into being self-sufficient as the United States is, and NASA can be. Also, you know, this is the first vehicle that was designed to be reused, right, and land on land, and it did everything that it was designed to do. These folks are some of the most talented that I've ever worked with. I've worked in the company quite a long time in many different platforms. Boeing builds some of the best and some of the greatest products there is, but again, human spaceflight is just that much different, right? And it's that much more attention to detail, that much more commitment, as I mentioned earlier, and it's very fairy tale-ish to be part of human spaceflight.
Ramon, you talked about how much work everybody is doing, you know, missing baseball games and all these kinds of things, and I know it's a test and there's a lot to learn, but that moment when you were with your team and you learned that there was a problem and it was not going the way you guys hoped and anticipated, what were you thinking? What was that moment like?
Yeah, you know, again, a moment like that is surprising to a lot of folks, right? Because of the fact that we do pay attention to detail and we make sure that our vehicle's safe and built with quality. That particular moment, we didn't have enough information to determine exactly what the anomaly was. We did make sure that everybody understood that these things do happen and it can happen. Right then and there, our focus was to understand what was going on and then call a lateral if we needed to. And we just
must have been crushed.
Absolutely, it was a disappointing time, especially when the team was so excited and so pumped for this particular moment. I told the entire team when I spoke to them before launch that no matter what happened, I was extremely proud of them. That Boeing company was extremely proud of them, and that after that launch, the nation would be extremely proud of them. And I believe all three still stand today. And the folks, we're going to lace up our bootstraps, we're going to learn, and we're going to become better, we're going to become faster, and we're going to definitely incorporate all the lessons learned moving forward.
Is Boeing maintaining any kind of capability to acquire like long lead items for potential third flight vehicles, or would you rely on the shell and so forth of the out-of-board vehicle?
So, you know, there's a lot of things in the works, right? We're taking a look at a lot of things. But right now, nothing that we know for sure that we're going to rest our hats on. But a lot of it is definitely in work right now that we're taking a look at.
Was there any other minor anomalies that were seen throughout the testing on orbit?
No, for the most part, again, the vehicle worked and functioned properly. We chose to continue to stay up and operate the vehicle as if it was there were no anomalies at all, and it performed.
So there's no hiccups, just had that one issue not happened, it would have been basically a picture perfect.
A lot of that's going to come after data reviews.
Yep.
Okay.
A lot of that would definitely come out once the all the data's assessed, kind of like I mentioned at the beginning of the interview.
Gotcha.
All right, so we're waiting on that. We do have an independent team that's going out and they're researching all of that. Once that independent team comes to their possible suggestions and solutions to move forward, production will then take over and we'll understand what to do to become, as I said, better, faster, smarter when it comes to space.
Mom, would you mind telling us your last name one more time, sir?
Yes, Sanchez.
And please spell that.
Sanchez.
And your position.
I am the Senior Operations Leader of the Commercial Crew Program. I'm responsible for production of the vehicles.
You said you want to move faster. How are you going to do that?
You know, again, it's by all the lessons learned that we incorporate. These are test rules, right? So we test and we test and we test for a reason. And we test and we populate the data, we implement the lessons learned, and we'll be able to build these things more efficiently, right, more safely, and deeply embed top quality into the vehicles. So utilizing the data that we learned from the data recorders and also just the vehicle itself.
So you think Boeing can be a company that can move quicker? I mean, is it capable of doing that?
Absolutely, without a doubt, right? Boeing company, we rest a lot of our path forward on innovation and our people and their ideas. And every single person in this building that touches this vehicle all have innovations on how to do things more safe, quality, and even sometimes faster. So that's who we depend on. They're the folks that make it happen. And that's who we have to lean on. Yeah. Absolutely.
If Boeing was building a Starliner for not NASA use, or strictly commercial use, is there anything at this point that you would design differently?
No, maybe just seat size depending on who it was. Right? That's it. Right? The vehicle is pristine. It's doing what it's supposed to do. It's a well-built vehicle.
How much of a professional pilot do you assess is, like, what skill level would be needed to
You got to go to Houston
operate?
for that.
We'd have to talk to my partner, Chris Ferguson, on that.
Okay.
Yes.
He'll say it's very complicated, the highest, most experienced staff.
And I would support him on that. Absolutely. Absolutely. You know, it's new, right? It's development. We've learned a lot along the way. It's the first time we're doing that, right? So that's why we test them. Right? So we did test a couple of vehicles. We've learned from that.
I'm going to be at the press site. Where are you going to be?
I got another over here. I'll just pull it in.
Okay, that sounds good. Thank you.
Julie, can I steal you for a second?